Algebra with Miss Schwartz. Today we're moving on. We've solved simple equations. We've solved equations that have multi-steps where we have to simplify. So we're going to use all of that today, but now we are going to have equations that have variables on both sides. So we're going to have to be able to deal with that. And you might think, okay, so variables on both sides, what does that mean for us? How are we going to deal with that? Well, let's look at it. We have some steps here, and yes, I want you to write this down. If you can simplify what it says so it's not so much writing, go for it. So the steps for solving a linear equation, okay, and sometimes not all of these are going to need to be used. So it says here are several steps you can use to solve linear equations. Depending on the equation, you may not need to use some of the steps. But I want you to write down this piece here. Steps 1 through 5. So, use the distributive property. We talked about that yesterday in class to remove any grouping symbols. So, distribute if you need to. If there's no grouping symbols, obviously you won't need to do that. Step 2, we're going to simplify the expression on each side of the equation. So, we talked about that last week, where we have to make sure it's as simplified as possible on both sides of the equation. Then step 3, that makes it a little different today. We want to make sure all the variables are on one side of the equation and all the constants are on the other side. And we're going to talk about how we can do that. Luckily, we can work with things like 15x, and we can subtract, we can add, we can move them from side to side, as long as we do it to both sides. Finally, we'll isolate our variables, which we've been doing the whole time, and then our last step is to check our solution. So we're just going to start with equations that have one solution to start. We'll explain what I mean by that. After a while, you'll see that we have some other options for solutions, but let's start with some examples. If you need to pause to write this down, do so quickly. So here's our first example. So we want to simplify anything we can. So I don't see the distributive property here, so we don't have to worry about that. It looks, if I look at each side of the equation, it looks simplified. I can't combine any like terms. It's as good as it's going to get. But I do notice that I have variables on both sides of the equation. So if we went back to that last slide, that step 3 that says collect all your variables on one side, that's what we're looking to do. Well, we can move our variables any direction we want to. Okay, it just depends on what we want to do. Remember, we want to get the constants to one, the variables to the other. So if I'm going to get the variables to the other, I notice that I have a variable and a constant over here. So I'm probably going to want to take this constant and move it over here with this constant. Sorry, this variable, and move it over here with this variable here. Well, how can I do that? Well, luckily, we can add 4x to both sides. If I take a negative 4x, which I have here, if I do keep, change, and add a 4x, it cancels out. So all I'm left with is 10. If I do something to one side based on our property of equality, I have to do it to the other. So I'm going to add 4x over there. Negative 9x plus 4x, you're just combining like terms there. So I would have negative 5x. Now, I have all my variables on one side, all my constants on the other. I can just solve by isolating the variable. I'll divide by negative 5. So negative 2 is equal to x. I can check this now. So 10 minus 4 times negative 2 is equal to negative 9 times negative 2. So this should be true if I got this right. So I'm going to be careful here. My integer rules tell me keep, change. So I'd have negative 4 times 8. So that would be, negative 4 times negative 2, which would be positive 8. And negative 9 times negative 2 is 18. 10 plus 8 is 18. So I can see that this is correct. Awesome. Hopefully you wrote that down. Next one we'll do together is a little more challenging. I need to take care of some distributive property pieces. I need to simplify anywhere I can. I actually have a fraction involved, so we really have to think through some of this. So I'm going to distribute. 3 times 3x is 9x. 3 times negative 4 would be negative 12 or minus 12. Same thing. Okay. I now have to distribute a 1/4 in. I don't want you to panic, okay? Think about it like this. 32x, if I distribute the 1/4 in, it's over 4. So 32 divided by 4 is 8. So we have 8x. And then 1/4, 56. Same thing here. Okay, so that would be, 4 goes into 5 once, and 16, so 14. All right, so now I'm checking to see if this is simplified. It looks like it is. But now I have variables on both sides again. So I want to get all my variables to one side, all my constants to the other. So unlike the last one, now I have variables and constants on both sides. So I have to make a decision. Do I want to move 8x this way, which would mean I'd move 12 over here? Or do I want to move 9x this way and move 14 over here? That really doesn't matter. It should be the same either way. I like to keep my variables positive. So I'm going to subtract 8x from this side, which leaves me with x minus 12 is equal to 14. From there, I can add 12 to both sides to isolate my variable, and I would end up with 26. Obviously, it would take a little bit more work to check this one, just due to time. I'm not going to, but remember, it's a very good way to make sure you know you got the answer right. So I want you to try these two on your own and check with a partner that you're working with, check with someone else, see if you got the same answer. Then you can always check with me if you have questions. So, not done there. What we've done so far is we've talked about ones that have solutions that have one exact solution. There are some other times that, or other instances, so there's special solutions to linear equations, and that's what we're going to talk about here. So equations don't always have one solution. There are times that an equation is true for all values, and we like to call that infinitely many solutions, meaning all the solutions in the world are the answer. Another way we write it, just to summarize it, is IMS. Okay. There's also an option that an equation is not true for anything, so that in that case we would have no solution. Okay, or some people write NS, no solution. And I'm going to show you examples of this, and then you're going to look at it a little bit yourself as well. So you may be wondering, how could this work? Well, let's check it out. All right, so A here, we're going to start working. We still are solving the equation like we always do, so I'm going to distribute. So 3 times 5 is 15, so I have 15x, and 3 times 2 is 6. So now I have them simplified on both sides. Now I have to work to make sure that I have all my variables on one side. So I'm going to move one of the variables over. So I'm going to subtract 15x from both sides. But when I do that, over here I'm left with 6, but over here 15x minus 15x is 0. So my question to you is 6 equal to 0? Well, this can't be true. No, 6 is not equal to 0. So our answer is no solution. There is no number that we could plug into here to make this equation true. If you have questions on that, please feel free to ask. So let's look at B. I'm going to distribute here because we do the same thing every time. We just got to make sure everything's simplified. So I have negative 8y minus 2 equals negative y minus 2. Okay. So right now, I have variables on both sides. So I'm going to add 8y to both sides. And when I do that, these cancel. So I'm left with negative 2 equals, and these also cancel, negative 2. Well, is that a true statement? Yes. Negative 2 is equal to negative 2. So in this case, no matter what number we plug in, we are going to have a true solution. So our answer is infinitely many solutions, or all real numbers is another way we write it. This is all real numbers. That's the symbol for all real numbers. You can write either of these, okay? So if I plugged 1 into here, it would work. If I plugged 2 into there, it would work. If I plugged 1,000 into there, it would work. Okay? So you may get a correct answer, you may get no solution, and you may get all solutions, right? So you have to be careful to make sure you're doing the steps correctly. So I want you to go ahead and try 4 and 5 here. You may get one solution, you may get no solutions, or you may get all of the solutions, so IMS, okay? So go ahead and try those. If you have questions, feel free to ask. Once you are done with that, please get your notes checked. I just want to see that you're taking notes and that you are understanding what we're doing. So make sure that your notes, I can look over them. And then I kind of check those 4 problems that I had you do. And then your homework here is page 15 and 16 in your journal. So not your textbook, but in your journal. All right, have a great day. Thanks for watching.